So this is the explanation for problem 2 of the FRQ. So for 2A, it says calculate the number of moles of electrons that must be transferred in the cell to produce the 235 grams of aluminum. It says the electrolytic cell produces 235 grams of aluminum, and the equation is 2Al2O3 plus 3C produces 4Al plus 3CO2. So what you're going to want to do is do some stoichiometry. We know that since aluminum has a +3 charge, that for every 1 mole of aluminum, 3 moles of electrons are transferred. So then we need to know how many moles of aluminum we have. So you do 235 grams of aluminum divided by 26.98, which is the molar mass of aluminum, and then times that by 3 moles, because for every 1 mole of aluminum, 3 moles of electrons are transferred. So you get 26.13 moles of electrons. For B, you're also going to want to do stoichiometry. You know that we have the equation T is equal to Q over I, where Q is charge and I is amps. So we know we have 26.1 moles of electrons transferred, and then you have 96,485 coulombs per 1 mole of electron. So you multiply that, and then you know in every 1 second, you have 152 coulombs transferred, because a steady current of 152 amps was used in the process, and amps is measured in coulombs over seconds. So then therefore it takes 67.49 seconds to produce the aluminum. And for C, it gives you temperature and pressure. So then it wants you to calculate the volume. So then you need to do PV is equal to nRT. But you need to figure out how many moles. So then you have to do 235 grams of aluminum, and then divide that by 26.98, so you get moles of aluminum. And then, we need how many moles of CO2. So then you use the mole ratio of 3 moles of CO2 to 4 moles of aluminum, which is 6.53 moles. So then if you use PV equals nRT, then it's V is equal to nRT over P, and N is 6.53, R is the gas constant is 0.08206, and the temperature is 301. And then you divide that all by your pressure, which is 0.952, and you get 169.49 liters of CO2. And then for D, it's asking why should the Al2O3 aluminum oxide, why must it be in the liquid state rather than the solid state? Because the electrolytic cell needs to be in the liquid state rather than a solid state, because without the flow of ions, the cell cannot operate. And if the cell's in a solid state, they cannot flow and nothing will react. But if it is in a liquid state, all the ions will flow and it will be good. For E, the cell potential is asking for the cell potential in volts, and you know that you have to flip the cell potential, the one that's more negative, so then it becomes 2.35 minus 0.83, so you get a cell potential of 1.52 volts. And it's asking for delta G, but it has to do with cell potential, so you need to use the equation delta G is equal to negative NFE, and we know that 6 moles of electrons are being transferred because 3 times 2 is 6, and that's how much you need to balance out the two equations. So you get -6 and use Faraday's constant, which is 9645, so -6 times 96,485 times 1.52, you get -879,943.2 joules. So therefore you get a delta G in kilojoules of negative 879.94 kilojoules over mole reaction.